Welcome to screencast session week 5 all pair shortest path using Floyd Warshall algorithm. So as you know that it's a all pair shortest, so it means that every vertex it wants to find out that shortest path from each of the vertex. For example, if you take that 5 vertices are there, 0 to all adjacents we are trying to find out, that means 0 to 1 and 0 to 2, 0 to 3 and keep on. Similar lines that one also used as another source and it tries to find out that shortest path from so 1 to 0, 1 to 2, 1 to 3 and keep going. So every pair we are trying to find out it. So let's have this particular function. This function takes that, so that is adjacency matrix as a parameter, because as usual that we are used that adjacency list so many times. So let's do with that adjacency matrix now. We are doing the initialization. Basically we have that number of rows and columns, so that's what we do. And as well as this particular shape of this input, it contains a two-dimensional array, so that 2 will come to the x. So what will be my adjacency matrix shape we are getting? The shape, it contains that rows, columns, and as well as what is the dimension of it. Basically the dimension is a two-dimensional. Now we do that infinite. So the infinity we are initializing with a float constant, so which we have done it all the previous example, that's infinite constant. So then we are trying to put it that the shortest path matrix. The interesting matrix here is the shortest path, which is all pair. So what I do is, so we are trying to do that np zeros and we are trying to initialize all of them zeros. So what could be the shape of it? The shape, it is that a three-dimensional matrix we want to create. So let you see that the rows, columns and columns plus 1. So what exactly this column plus 1 is? It's a three-dimensional one. For example, if you have that 8 columns, we are trying to create that. So another 8 particular columns, like 8 dimensions you want to create. So what exactly 8 cross 8, and as well as that 8 dimensions it will create. So similar kind of 8 cross 8 matrices, we are creating another 8 dimensions. So now, so let's do that filling of the shortest path matrix. So whenever there is adjacencies available, we are filling with 1, and as well as that we are trying to put it that whatever that weight available. So we do that for I in range of that whatever rows available, and another nested loop we are repeating for j in range. We are trying to fill up that j in range of the columns, and then if there is a adjacency matrix which contains that I and j and 0, where it contains that it is having existing path. Whenever path is existed, it is represented with 1. When no path is existed, that so it is represented with 0. So when there is a path is available, the shortest path is initialized with so I and j, and whatever so far weight is available, the weight is going to be assigned. So that adjacency matrix I and j and first tuple value. The first tuple value is definitely it is a weight. So this is initializing if and only there is a existing edge is available or adjacency is available. If there is no existence or adjacency is there between that, so I and j, so then we are trying to initialize that sp. So I and j 0, it's initialized with infinite, because there is no reachability. So whenever there is no reachability, we don't know what time it reaches, so that it's infinite. So now we are repeating, there is a loop which it is repeating n times. So this is the outermost loop, k in range of that, so 1 2, so the columns plus 1. So it is that external versions is maintained. For example, we are taking that first source, and as well as we are trying to find out the all shortest path from first source to all other pairs. Similar lines, second source we are finding out, and second source to all other vertices we are, so that every time this particular source of k is changing. So now, so checking of that if there is existing path is available. So for that we are using, there is 2 nested loops we are using for I in range of that, so rows number of times, and for j in range of that columns number of times. So inside we are updating, so whatever that existing distance is minimum, or via k it is minimum. So here we are updating that sp of that I, j and kth version. so which is nothing but k dimension, we are updating either minimum of that direct path, direct single source path between I and j and k minus 1, if this is a minimum, or it might be that combination of two things like I to k and k to j. So that's what we are trying to find out it. So because k is working like one particular medium kind of vertex, so we want to reach that a to c. Either you are directly reaching a to c is a minimum, or you are trying to reach that a to c, that is a to b and b to c. So that's we are trying to find out it. So by adding the two paths, so that is I to k minus 1. This is plus we are trying to reach, that's we are trying to reach that a to b first, that's plus then k minus 1 to j, then this k minus 1, the last k minus 1 is a dimension. So either you reach that I to k first, then whatever existing distance is available, that weight, and as well as that from k to j. So to reach from I to j, there is a k minus 1 is the medium vertex, whatever via k you are reaching. So after all doing that, whatever minimum out of that existing direct path is a minimum 1, or indirect path is a minimum 1. Out of this, the minimum 1 is assigned to the k. So then finally the result what you return is that the last dimension of that columns. So that return the last dimension, because we have 3 dimensions of this SP. So we don't want first dimension, so we don't want second dimension, the third dimension we want it. The third dimension, it contains that complete updated value after completing of all pair shortest path. So this particular directed edges are created using this graph. This graph is already available in your GitHub notes, so you can check it that there it is available with all pair shortest, like 0 to all other vertices you are trying to find out it. So 1 to all other vertices you are trying to find out it. 7 to all other vertices you want to find out the shortest path. So let's run this. We are trying to save this one. Let's run this. Yeah. So hopefully you got this one. So if you could see this first particular row, it is that 0th vertex to all other vertices, what is the shortest path? Similar lines from the first vertex to all other vertices. So what is the reachability? For example, if you see that the first vertex to, so maybe you are trying to reach the last vertex, maybe it could be the last one. If there is no reachability, it will tell you that with infinity, because there is no possibility of reaching. So similar lines that, so if you are going for this last vertex, maybe it is that 8th vertex or 7th vertex, so it is not reachable. So maybe that's not reachable to the 0th vertex, but that is reachable to the first vertex. So whenever there is a reachability, there is a minimum shortest distance is available. If there is no reachability, it is defined with infinite. So hope you understand. So thank you very much. Have a nice day.